Hello, so let us understand one more time the concept of signed binary integers. So out of the three forms in which signed binary integers can be represented, this is the first form called as signed magnitude form. So for an example, 8-bit number is shown is decimal equivalent is 5, and this is the way signed magnitude form can be shown, where the MSB here, which is 0, tells us this is a positive number. That's why we have seen here this is positive decimal 5. And if it is a negative 5 in decimal and using sign magnitude form, we will see how that can be represented. Another form is the ones complement form to represent a signed binary integer. So again, if you want to represent a decimal 5 in the ones complement form, it is similar to what you can see here. It is same as the signed magnitude form, and both signed magnitude form and the ones complement form, they are similar to the way unsigned binary integers would be represented. So for the decimal 5 using unsigned way of representation, you will have the same bit representation, say in the 8-bit form. The final and the third form is of the signed binary integers is the 2's complement form. So again, decimal 5, it is you want to represent in using 2's complement form, it is same as signed magnitude, ones complement, or unsigned. And this is the MSB for all the three possibilities. MSB showing 0, that tells they are positive numbers. So it is the same way of showing signed binary integers, and this is same way you have showing unsigned binary integers. What about showing the negative numbers using the signed binary integers? So three forms: signed magnitude, ones complement, and two's complement. We'll see how negative 5 will be represented. So before that, we note MSB is always 0, telling us these are positive way of representing the same number, that is decimal 5, and these are all signed positive integers, signed positive 5 in decimal. Let us move to understand how the negative 5 will be represented. So the way to do that is first show its positive form. So again, in the 8-bit form, this is the way we write decimal 5. 0 is the MSB showing and telling this is a positive binary integer. The first way to show the negative 5 using sign magnitude is simply flip the MSB. If it is 0, then it becomes 1 and all other bits remain same. So in sign magnitude form, -5 will be shown as seen here. How about -5 using ones complement? To do that, what you do is you look at this top number, which is the positive number, and all the bits here, you just complement them. So 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1, and so on and so forth till you reach the MSB. So 1, 1, 1, 1, 1, 0, 1, 0, which is the ones complement of this number, top 5. This is how minus 5 is shown using ones complement. So this is the negative form. Finally, you want to represent the minus 5 in 2's complement. So this is the minus 5, and you want to represent using 2's complement. So what you do is first show the number in the positive form, which is shown here in the red. Take its ones complement, which is shown in the third row. We have obtained the ones complement. Then add 1 to the LSB of the ones complement form. And then you get sum and the carry as a normal binary addition. So you show that after adding n 1 here to the LSB, then addition here 0 plus 1, sum is 1, carry is 0. 1 plus 0, sum is 1, carry is 0. 0 plus 0, sum is 0, carry is 0. 1 plus 0, sum is 1, carry is 0. And you repeat this till you reach MSB. Finally, 1 plus 0, sum is 1, there is no carry again. So then you add negative sign to this final bits in binary form, which is 1, 1, 1, 1, 1, 0, 1, 1. So you see that this is minus 5 in 2's complement form. So what is to be noted here, in the negative numbers using signed binary form, MSB is always 1. So in the 2's complement, you see MSB is always 1. In a 1's complement, MSB is 1. Using signed magnitude, MSB is also 1, showing this is the way signed binary negative integers are shown. When you see MSB to be 1, you can say these are all negative integers. So they are signed negative integers. So hope you found this short tutorial useful to understand 3 ways of representing signed binary integers, both positive and the negative.